x squared when you integrate that. So minus 2x squared natural log 3x plus c. So this is your final answer here for this one. And that's what I was referring to, whether there's sort of a huge learning curve here for these. Now, let me go ahead and just calculate this with a calculator just to confirm the result.
Okay.
But you're doing integration by parts, and then it looks like some other, you have some revolutions of solids, things like that. So just keep that in mind here. So yeah, x squared, 2x squared, natural log 3x minus, yeah, this is correct.
Awesome. Got it.
All right, so the next one here, number 2, I'm just getting a snip of this. Okay, so number 2, label it. It's also an integration by parts. It's a little different than the first one, but I'm just going to go to a calculator. I'm just using a Wolfram Alpha. There's other more specific ones, but this one allows me to do a lot of the calculations for you. I don't like that answer, man. Oh, is this a rounding problem? It is.
Do not round until the final answer, then round to 4 decimal places as needed.
There we go. That's fine. That's good. There's another kind of shortcut, which is to use that we used an integral estimation tool, but you can generally get a lot of these give you the number as well. Oh, there we go. Let's log, not ln. Okay, so the answer to this one, once I throw in the calculator and then I did it by hand as well, 639, no, 4 decimal places, sorry, 6388. 88 like that.
Okay, perfect.
The next one is also integration by parts. Oh, they finally tell you that. Maybe they said that in the first ones. I don't know. I mean, this is like this is hard for even if you're in the classroom, this moves pretty quickly for students to be able to do. It's a lot to ask. Assuming integral is an integral. Yeah, that is it. Okay, so here is your answer for this one. 1/256 e to the 8x 32x squared minus 8x plus 1 plus c. Big capital C on that.
Minus 8x plus 1. Okay, let me double check that. All right, got it.
All right, so the next question 4 is also an integration by parts, but whenever it says to, actually says down here to round your answer, you can always just go to a calculator with that one. So you're integrating this function 30t e to the 2t dt from 0 to 2, because this is the first 2 days. And you throw it in the calculator and you get 1,236.
Awesome.
If we have time at the end, be happy to go through more of these as needed. Okay, so here is a new problem for us to look at. Okay, so this is what is this, problem 5? Does that sound right?
Yes.
Okay, 5. We can get this 5 right there. Okay, so let's find the volume of the solid by revolving the region bounded by the lines in the curve. So y equals square root of x looks like this from 0 to 10. Here's 10, here's 0. So you're taking this region and you're spinning it around the axis And if you're wondering what that looks like, it's like a vase, whatever, but it's solid all the way through. I don't know if there's a better example. Maybe it's like a piece of fruit, like a banana that you've cut off sort of at the end.
Oh, yeah, I
That's
see
what
what
it
you're
looks
saying.
like. That's sort of interesting to think about, things like that. So in terms of like what you do here, though, it's the integral from 0 to 10, 2 pi. I'm sorry, that's not correct. It's pi r squared, and your r is this radius of revolution. So let me draw an r. So like your r is the distance from x-axis to here. This is your r, but your r is really a function of x. It's really that square root of x. So your radius squared is the square root of x squared, which is x, and that's what goes in this integral. So instead of r squared, you end up plugging in x dx.
Okay.
So then you find your antiderivative, 1/2 x squared, pi outside here from 0 to 10. You plug in 10 in the top, and you get 10 squared, pi 1/2 10 squared minus 0 squared. So it ends up being 100 pi over 2, or 50 pi as your final answer.
Okay.
So let's see. We'll see if we get another one like this. Yeah, I get another one like this. So around 6. Okay, find the volume of the solid by revolving the region and by the lines and curves. So here's e to the x. Here's -2. It's not to scale, and there's 8. So you're revolving this region around the x-axis again. So I mean, you can maybe visualize what that looks like. Some sort of maybe like it's circular.
Right.
And
Okay.
you're done. But it's
Funnel.
solid, and it's a funnel, but it's not cut out. Yeah,
Yeah.
that's a bad funnel. Everything's coming out the top. Okay. So in terms of what you do here to integrate, it's from -2 to 8 pi r squared dx, and your r, your radius is this thing right here. Your r is the function here, e to the x. Okay, so this is when this is when, again, I would just go right to the I go to the calculator here, but it's e to the x squared, which is e to the 2x, and I'm just going to go to the calculator here to get this, but that's the idea.
Okay.
What else can I say here? E to the 2x, integral e to the 2x from -2 to 8. So when I use these calculators, I actually don't put the pi in, which is kind of it's something you learn over time. Let me not do it in red, because the pi sometimes causes the calculators to not work properly. And it's just a constant of integration. So it ends up being e to the 20th minus 1 pi 2e to the 4th out in front here. This is your, so that doesn't mean anything. It's just that is what it is.
Okay.
It's just a weird number.
Okay.
All right, so number 7 here. You guys, so one of the things that students really get frustrated is because they don't remember how to graph these things, and that's where they really struggle. So this is 1 minus x squared here, and you're revolving it around the x-axis again. So it's some sort of maybe a sphere. I'm not actually sure, but you integrate from the bounds here, -1 to 1 pi, and then your radius this time is that 1 minus x squared. It's whatever the y value is what it generally is. And so it's still the pi r squared, but I'm going to go right to that calculator again and get that number for us. So it's 1 minus x squared from -1 to 1. Wouldn't you know, it's already been done. It was in the search history of this thing. So it's a common problem students are doing right now. There's your 16 over 15 pi.
Alrighty.
All right, so we're moving on to a new topic. So I'll do this one by hand and make a little more effort for comments here. 8. All the numbers the same so far in this? Okay. All right, so I'm going to graph this function and then snip it in because we do the interpretation of this is important. X squared minus 3, but we're only going from 0 to 5 and something like that. Okay, let me snip that in. So let me change the window slightly, make this a little bit easier. -2 to 7. I don't know, -5 to 20. Does that look a little better? A little better. Okay. Okay, so the area under the curve is the stuff I'm about to shade in. So this region down here, and then all of this above. So from last time, we know that that the integral gives, like, it negates the area on below and then it adds the area on the bottom. So when it asks you to find what's called the average value, find the average value of the function, the geometric interpretation, the picture here is it's a horizontal line. And actually, let me get the answer first, so I don't put this in the wrong spot. Should have done that first. Okay, integral. All right, so this line right here represents the place, the horizontal place where the area above equals the area below.
Oh,
And you have to
okay.
decide. I mean, it's maybe doesn't, I don't know, maybe it looks like it should be a little higher or not, but that is the geometric interpretation. Now, in terms of how you do
Okay.
this, the formula is 1 over b minus a to b, f of x dx. So your a and b are the intervals. So it's 1 over 5 minus 0 from 0 to 5. And then your function x squared minus 3 dx. And then I just went to a calculator and got 16 over 5 as your final answer. But that it's got a significance, but in this problem it doesn't mean much, but it is literally the area above equals the area below.
Okay. Got it.
All right, so 9 is the same. Okay, so find the average value of the function. So it's 1 over 22 minus 6. That's the b minus a from 6 to 22 square root x plus 3 dx. And then I just go to a calculator, and I mean, these can be done by hand. It's just a matter of time. I think we talked about that a little bit in previous lessons. I'm sure there's things that you do in work or personal that, just are a function of saving time to do here. (49 over 12).
Awesome.
Okay, so number 10 is like an application problem, but it's the same. So this is actually more relevant. I guess we could spend a moment here. Hopefully you've got some retirement going on, and
Oh yeah.
if you're frustrated, I think I'm extremely frustrated. But the let's just assume that this thing is actually true. We don't know what this curve looks like, but the average value, like let's just say the curve looks, I guess at 30 plus 10. Um, this one's weird. It actually trends down, which we wouldn't expect. But the idea is that in the first 7 years, there's some sort of like average value that you can expect on it. Some average value line on it,
Mm-hmm.
which we'd actually like to see it sort of trending up. But it's like what's its kind of value in terms of that. So it actually isn't that good of an example, but well, maybe it is right now. But the limits are 1 over 7 minus 0, 30 plus 10 e to the minus 0.05 t dt, and this will give you the value. They probably don't do it in this course, but you can actually do annuity future values with integration, although it's faster to do in Excel, but it's the same idea, like you're compounding over time and things like that. But this one's just going right into the calculator again. 30 plus 10 e. Oh, and I generally switch to X. So if I gave you any answers earlier, I think they were all in terms of X, all the problems we've done, but you might check to make sure there's none in terms of T.
Okay.
It's a little thing here. So integrating from 0 to 7, and the answer here, what does it say to round to? The nearest cent?
Sorry.
Looks like
Nearest cent, yeah.
38.44. So that's the average value of the stock, but it started at 40 and it went to well, it's going to approach 30. So that's pretty bad. I mean, you wouldn't want to buy that. I mean, unless you thought it was going to go up for some reason.
Mm-hmm.
And there's no like hidden math to like predict stock prices and market. I read there's a really good book called A Random Walk Down Wall Street. It used to be required reading for finance students. And it basically covers all the strategies over the years that people try to use and disproves basically everything about them. So the only strategy this author believes works is to buy and hold forever.
Wow.
And in some ways he's right, because it will eventually go up. But he covers kind of interesting. There used to be this thing called this tulip bulb craze in the like 1600s. Really interesting. People were nuts over these tulip bulbs that were coming out of in somewhere else in the world. So anyway, all right, so 11 11 is another one of these integrals, but I need to look this one up for the formula. Present value. Okay, let me all right. So they say the function fx represents the flow of money in dollars per year. So basically, they're saying you put $700 per year into an account, and a 5-year period at 5%. So you're getting a 5% growth rate continuously, which we know is not true. It's never continuous, but it wants the present value and the accumulated amount of money flow at t equals 5. So these are just formulas. I do need to look them up because I don't have them readily available. Excuse me. So let me go in and look for those. I mean, as we know, it's not continuous, because you look at your statement and one day one quarter it's up, one quarter it's down, and boy, it's pretty frustrating for that. So the present value, we want the present value and we want the accumulated value. Okay, so the present value is the integral from 0 to 5, 700 e to the minus 0.05 t dt. I believe that's correct. Let me, because that takes into account the decrease in value. Okay, and then the accumulated value, I don't think that's right. Let me just look at one more reference here. Okay, so I think I've got it here. So let me just do this calculation.
Mhm.
Roll 700 E minus 0.05 X from 0 to 5. Okay, so this ends up being $3,096.79. So the idea there is that if you put in $700 a year for 5 years, that's $3,500, but it's worth less now than it will be then. So that's
Okay.
part A. Part B is to take the present value of your investment and then you multiply it by the interest rate, continuous interest rate times the number of years, which is 5 years, like this. So that'll just go into to a calculator here to figure out. And that's what I think you care about is cumulative amount of money flow. 36. Okay. So I just get this calculated. Okay, so this is what its value is worth. $3,976.36, which is I think what you care. It's like what you care about. When we're investing, we just want to know what. Well, you'd like to know what it's grown to, which is what this is trying to show you.
Right. Okay. Okay.
I hope that's the last one of those because we're now almost behind schedule here. Even doing this. Nope, we got to do another one of these. All right. So another one of these. This is question 12. So this one will go a little faster. So the present value A of this is the integral 900 e to the 0.03x times e to the 0.08 this time x, because that's what it's growing at, minus that dx, and you're integrating from 0 to 5. So we'll do that. Go grab that number. 900e. Wait. From 0 to 5. Yeah, looks right. Okay, so this is $3,981.59. The first one.
Mhm.
And then part B, you take that number you just found, 3,981.59, and you multiply it by 0.08 times 5 years. 0.08 times 5 years. And that gives you, that's what it's grown to, $5,939.83. All right, so we'll need this again for the final, so be good to have that.
Okay, got that one.
And yet another one of these 14. It's a little bit shorter, but there's some overlap here in finance. Okay, so this one, continuous streams. So they want the present value this time. So that's the integral from 0 to 2, 34,000 e to the minus 0.05 t dt. So we did that a couple of times. Just let me go.
Hey, Matthew.
Yeah.
I think we need 13. I think we did 11, 12, and then 13 is.
Oh yeah, there's another one. So this is 14. So I'll come back to do 13.
Okay, yeah, that's fine. That's fine.
Yeah, good. There's a bunch of these. Yeah. 14. So let's see what we got here. 900. 34,000. e to the minus 0.05 from 0 to 2 years this time. And what does this want you to round to?
Nearest dollar.
Oh, good, because I didn't get as many decimal places I wanted this time. There we go. All right, so we'll go back to 13. These are horrible. I mean, they're not that bad in terms of the calculations, just we're missing the meaning of these. You know, these numbers don't mean much because they're not, you know, like my situation or your situation or a friend's situation where you. So part A, you integrate that function that they give you, but it's always times e to the minus 0.05 or whatever the interest rate is. And you go from 0 to 10 in this problem. So you definitely need a calculator for that. That's the present value of it. So let me go back to the calculator here. All right, so we can use that. So I got 1200. And see, these don't make any sense because you don't, most of us invest money like consistently in the market. These are saying like the money flow is this curve right here, and this curve right here looks like this. And that's not, I mean, that's not typical. I mean, it could be, but it's, you know, most of us just put the same in each time, or maybe randomly throw in a little extra. But this is some sort of assumption that you're going to do something, none in the beginning, a whole lot more, and then taper off here with that. All right, round to near cent this time. Oh boy.
Yeah.
It didn't like that. See if I can force it to do it another way. Times 100. So if I divided the answer by 100, multiply the answer by 100, that didn't work either. It's near cent. So the problem here is it didn't round to the night. It didn't give me another decimal place. Let me see. There's okay. Yeah, I got to do this one by hand. Okay, let me do that. X equals 10, comma. Syntax error. Okay, there's that number. So that's top. Look at the bottom. See if that matches up. Why doesn't that match up? Minus 100 at e to the minus x over 20, 10, 20x squared. X squared minus 560x minus. Oh, I missed that again. That's why. Okay. All right, we'll come here, top, bottom. Okay, so here is the answer. 20,277.64. All that work was to get this last digit decimal.
Oh, wow.
Because I couldn't, it wouldn't give it to me. The calculator cut stuff. Now, you
Jeez.
take that result, take that 20,277.64, and you multiply by e to the how many? What's our 0.05 times 10. Okay. Times exponential. Okay, so this becomes 33,000. This is part B now. No comma. 432.18.
All right. Jeez.
All right. The rest are very, very fast.
Okay.
Once I show you one of them.
Whew.
Yeah, so up to 15.
Yeah.
All right. Okay, so there's a really formal way to do it, which I'm not going to do. And then there's an informal way, which we're going to do. So the antiderivative of this thing right here ends up being -3/2 times 1/x, and you evaluate it from 2 to infinity. So 1/infinity minus -3/2 times 1/2. So 1/infinity right here, this is 0, which is not correct, but that's like, it's not mathematically correct, but that's how we're going to interpret it.
Okay.
So this whole thing on the front here becomes 0 because it's 0 times a number, plus 3/2 times 1/2, which is 3/4.
Okay.
Right. So the next few problems, I'm going to just verify this with the calculator again, are the same, where you're integrating from a number to infinity or minus infinity to a number,
Okay.
and they all are pretty fast. There's a whole part of calculus where you talk about what's called convergence and divergence, and you're omitting that here. They're either giving you problems where it works or doesn't work.
Okay.
Things like that here. Okay, so this next problem right here, this one actually diverges. There's this thing called the p-test. So the exponent on the bottom has to be greater than 1. P has to be greater than 1 for this to converge. And you can see that the exponent you have is 1/2. So this one diverges.
Sweet.
All right. The next one here, I'm going to go right to a calculator for this one. I believe this one also diverges because we're going in the wrong direction, but the calculator will tell me that as well. So we got 4 over x to the 4th from minus n to 3. And this one also diverges.
Okay.
This next one also looks to diverge, but I'll just verify that. I take that back. Okay, so the antiderivative of this one is -9/10 x to the 10/9 power, which if we write it slightly differently, it's the 9th root of x to the power of 10. And we have to evaluate that from -infinity to -1. So when you put -infinity in the bottom here, because you're raising it to the power of 10, it's essentially becomes positive, but it's super big. So this whole thing goes to 0. So it's 0 minus -9/10, 9th root of x of -10 to the power of 1. So these positives, negatives cancel to positive. Because you're raising -10 to the power of 10, that's positive. The 9th root of 1 is 1. It just becomes 9/10. over 10.
Okay. Well, okay.
All right, so the next one does converge. So this one, just go to the calculator, but this one's nice. This is a known one that works out pretty nice. It's used in probability and statistics, and it's nice in the sense that it actually has some physical meaning. It's a distribution. Oh no, I used the wrong variable. Not done. So this ends up equaling 2.
Okay.
Okay, 20 is yet another one of these. So we're going to go right to the calculator, get a 14 over x natural log of x from 2 to infinity. And this one diverges.
Okay.
All right, last one. So this would be an integration by parts, and then a indefinite integral, or I'm sorry, improper integral. And let me just go to the calculator, see what this one does. Eight x to the 7th, e to the minus x over 8 dx. So this one actually goes to 0. So it does converge and it goes to 0.
Okay. Okay. So what's just curious, in this hint that they give you, it says note that this, what's LIM?
Limit
Okay.
xn e to the minus x goes to infinity. So that when you find the antiderivative, the antiderivative of this is minus e to the minus x to the 8th, evaluated from minus infinity to infinity. And you're supposed to use this to be able to answer that.
Okay.
I'm not really sure why they're giving you that hint, because it doesn't seem like it comes into play. Because that's 8x to the 7th negative there, 8x to the 7th. Yeah, but the idea here is that it ends up being in both cases minus e to the minus infinity plus e to the minus infinity. And this part, this is what they should have been telling you, is this part always goes to 0. I guess they're saying even if there's a polynomial out in front, it still goes to 0.
Oh,
But
okay.
it ends up being 0 minus 0 or 0 plus 0.
Okay. All right, I'm all good. What do you feel like there's benefit added if you want to go over a problem that we did, or if I should check my answers or anything?
Should certainly check your answers.
Okay.
That if we need to, if you're concerned at all about that, and then I guess I can make some comments in the time we have left. And by the way, this I could have made this last like 2 hours, just so you know,
Okay.
like this could. There's I'm trying to be as full disclosure as possible with you on these. Like there's going through this by hand is very long.
Okay.
Double or triple the time we just did. But anyway, yeah, why don't you see if your answers are here, or if you have questions.
Okay, one is good. 2 is good. Four is 1, 2, 3, 6, 5.
5 is down here, 50 pi.
Good. 6. Good. Good. Yep. Good. Yep. Good.
And 10's good. Okay.
That one's good.
Scroll down here. Couple more.
Okay, 13.
So we
Oh,
went
yeah.
out of I went out
Yeah,
of order.
I'll do 14. Yeah.
Okay.
6, 4, 7, 1, 1, 6. Yep. And then back to 13. Good. 15. Good. It diverges. 17 also diverges. 18 is 9/10. 19 is 2. 20 diverges.
Yes.
Okay. And 21, we got 0. Okay. All right, let's submit this. Submit. There we go. We got 80%.